Hey, what's going on, guys? Kamagigins here. Here is an update on my KIM-1 emulator in JavaScript. So from now on, the stop button is triggering the non-maskable interrupt. The reset is also working, but one of the most significant things and features to consider. So from now on, we can use the single step in mode, which I will demonstrate right in the moment. And also I've added the online 6502 assembler, which is taken from the Easy 6502 project by Nick Morgan. So Nick Morgan has adopted the existing 6502 simulator, which was initially intended for showcase how to code in 6502 assembly, but that had its own environment. It wasn't the emulator, it was a simulator more like. But I've adopted the assembler itself, apart from the rest of things, just to assemble the code for KIM-1, and then we can upload the code into the KIM's memory. So this speeds up the development basically. But again, I really prefer the hardcore way of just writing code on a piece of paper, then just doing hand assembling and then inputting the codes from this magnificent keyboard. But again, for you probably would be a bit more convenient to go with a coding and assembly. So let's first have a look at the feature of single step in here, and then we will go for a test. Then we'll test how to lit up a single segment on this LED and like on all of the LEDs basically. So let's write a simple program. So I want to say load to the A register, I want to load the value of 10. To the Y register, I want to load the value of 11, and to the X register, I want to load the value of 12. Now if we go to, so here we have so-called machine context. So we go to 00F3. So here, we have the stored value of the A register, whatever it is there here for Y register, for Y register here for X register. So there may be whatever basically. So let's go to the address 0000. Now let's assemble the code. And another important thing, it asks us where is the origin, where the code should start from, and we'll play around with this a little bit later on. So we have a look at the hex dump, then address of 0000, we have our code starting. And now if we want to put these values into the, if we want to dump this into the KIM's memory, I can simply say upload, and now we have this data in. So A9, now just open the hex dump here, make it always on top, then plus, then 10, then A0, then 11, then A2, and then 12. So all of the bytes are just right in. And I go back to 0000, and let's single step the program. So if I press go, and it only executes the very first instruction. So if we now go to 00F3, for instance, now you see we've dumped the value of the A register. So here is the address for an A register to be dumped into is 10, and the next two should be zeros. No, they are not zeros, but at least they are not the values that we have here. Okay, so I press program counter to drop back to where we've dropped our execution, and press go again. So now this has been executed. So we go to 00F3. We still have 10, but here for Y register 00F4, we have the value of 11 and still have some previous value for X. So now we go back to where the program counter has stopped and press go again, and then you say 00F3. So we have 10, then 11, and then 12 in the register X. So this is how the single stepping works. And if I just grab this code, update my page, paste it, and let's say 000F3. So yeah, now here we just have the zeros. It's also possible. So if I just assemble and upload the code again, and now go to 0000, and go. Now it executes the entire code, but still, once we've hit the break statement, because there was 0 after, and if we go back to 0, 0, F3, still we have all of this value 10, 11, and 12 being dumped into this memory locations, just for our convenience to keep track of what kind of values we have in our registers. So I hope this is clear. Now, another little trick. So for instance, here I say start, and here I say jump to start, and assemble, and make a hex dump. So here we jump to the absolute location of 0, 0, 0, 0, for C stands for unconditional jump. But if we do the same, but we change the origin to say hexadecimal to hundreds, okay, and yes, hexadecimal to hundreds, okay, going for a hex dump. Now it starts from hexadecimal to hundreds and go into 0002, which is the little endian of byte order representing this exact address of 200 hexadecimal. And now if we hit upload here, then our code, this code would be uploaded at the location 0200, and we have now our code being duplicated here as well. So I hope this is clear. All right, so yeah, I just want to update the page to start it from scratch again. And now let's play around with lighting up the separate segments on the LEDs. So here is how we can go for it. So yeah, that's probably like so. So I can say, yeah, let's say lead up, right? And here I want to say LDA, so into the A register I want to load the value of 0, and then I want to say jump to subroutine, and I need this one output, the 7-segment code stored in the A into the A register, so 1F for E, 1F for E, and by the way we can define it. So if I say define out, for instance, we can call it however we want, and here I can say out as well and bring it in. Okay, and here if we just jump back to our lit up, okay, then if we assemble, upload, and run the code, you see like nothing is being lit up anymore, and that's because we just print an empty code to every segment like one by one. And now let's say here I say 1, and here is another trick. So if I just assemble and without stopping it, well, I can actually stop and then going back to 0000 and run it again, and yeah, have the same result. Yes, I forgot to re-upload the data. Go, yeah, now we have another segment being lit up here, but here is the trick. So for instance, yeah, and here I just want to give you some idea of how this 7-segment code is actually working. So now for instance, if we say 02 and assemble and upload instantly without making stop and go again, because this upload just dumps the bytes into the memory like on the go, so this kind of works. Then we know that to encode this segment, this one, we need to use this 2. Now I'm going to be using the powers of 2, so 4. Next, and we have this segment, so it goes kind of like here, and now 8. Okay, assemble, upload, now this one, so here we can say 8. Now 16 in hexadecimal is going to be 10. Okay, so here we have 10, and then 32 in hexadecimal is going to be 20. Assemble, upload, so here we'll have 20, and 64 in hexadecimal is going to be 40. So assemble, load, and we have this one. So here I can just say 40. In order to lit up some custom segments here. We just need to bitwise OR the values that we're supposed to be having here. So for instance, if we bitwise OR all the values, like FF, this is going to be FF, then we'll have the value of 8, or B, if you want to treat this as the character. So for instance, if we go FF, then we can assemble and upload, and we have like all the segments been lit up here. So far so good. So just probably to give you an idea, so if we have let's say going back to all the zeros, just to give you an idea as to how this can be done. So for instance, we want to type the letter H. So we want this segment, this one, this one, and this one, and this one, and this one to light up. So let's first convert them to binaries. So 0, 0, 1, 0, 0, 0, 1, 0, and then this 40. So 0, 1, 0, 0, 0, 0, 0, and then 10, 0, 0, 0, 1, 0, 1, 0, 0. No, 10 is like this, sorry. And now 4, 0, 0, 0, 0, 0, like this. And 2, so this is 1, 2, 3, 4, and the fifth segment. And here, 0, 0, 0, 0, 0, 0. No, this was already. Okay, let's go step by step. So starting from this one, for instance. 2. So this one is 2, 0. This one, okay, let's start from scratch. 0, 2. Okay, this one is going to be 4. This one is 4, 0. This one is going to be 1, 0. This one is going to be 0, 4. Okay. Yes. Okay, and now we need to bitwise OR. So we need to perform this bitwise OR operation all along the way, like this. And what we got in return, so this is going to be 0, 1, 1, 1, 1, 0, 1, 1, 0, which is going to be equal to 76 hexadecimal. So this is 76 in hexadecimal. And here, not a surprise, if we input the 76, then this one, and this one would lit up, and it's kind of like the letter of H. So I hope that's clear. And if, let's say, you want to have the letter of E, for instance, in this case, you can just imagine that you have FF, like all the bits been set to once, and then you just need to get rid of only this bit and this bit. So bitwise end with 2 and bitwise end with 4. If I do it in my head, it would be F like 1, 1, 1, 1, 1, 0, 0, 1, and this is going to be F9. So if I say F9, it should print the letter E. Okay, let's check it out, and it does really. So yeah, this is how you can code, this is how you can program separately every segment in separate. That may be quite useful, and that's how you can print some words on the display of KIM-1. Not only on KIM-1, but literally on whatever 7-segment LED is using these codes. Now I'm not providing sort of a hello world program yet using this technique because I'm still debugging the emulator, and I just need to make sure that it works 100% properly. So I need to make a bit more tests. And also, you see, like since the last video, now it's a little bit flicker. The display is a little bit flickering, and it's a trade-off to be able to actually light down the display like this, because the previous version didn't have that flickering, but the previous version didn't have this opportunity to light up, to power off every single, like if you want to power off this one or this one, they're just doing this sequentially. So we didn't have that option because that was a trick just to if the emulator gets the value of 0, 0, it just returns without doing anything. But yeah, that did violate the functionality, so I need to come up with a different hack, which doesn't really seem to be working that nicely. So sometimes it flickers. Most likely it doesn't, but yeah, sometimes it might be flickering. So depending on my video recording software, it might be a little bit different. But anyway, so I hope you got the general idea, guys, of how this sort of things work. And yeah, probably one last thing to bear in mind. So we go into a hex dump. So let's say you want exactly this. Let's say you have the hex dump. So if I copy this one and I just update, okay, so there is a DCB, which I believe stands for declare byte thin, that we can use in order to input already like the binary data. So if I just make some commas here, like so, and assemble, and then for instance I can go for disassembling, and this disassembling tells me what in particular I'm trying to. It won't be assembling the addresses to variable, like to labels, definitely, but at least it gives you an idea regarding the opcodes, which might be incredibly helpful. And this program still can run. So if I just upload this program and run this program, it still does exactly the same thing it was doing before. So this is it from my side, guys. I hope you've enjoyed watching this video. Thanks for watching. Until the next time, and take care.